So today we're going to talk about User Datagram protocol versus Transmission Control protocol. So, did I say that wrong? User Datagram protocol versus Transmission Control protocol. So what is the reason why live streams can be pretty bad, where the sound is distorted, the picture is distorted, you got all kinds of weird visual artifacts happening where it's just like, whoa, what's going on? And you just name it. Any kind of distortion you can think of can happen during a live stream. Maybe 1 minute the person is speaking, today we're talking about UDP versus TCP, or, the voice gets lower or higher or who knows what. So what's the deal? It's 2017. We got broadband everywhere. So why is it that we have these issues with live streams? Well, I'm going to tell you exactly what it is and what the solution is, but you're not going to like the solution. You're not going to like the solution. The solution is really impractical, and it's a matter of you deciding what the priorities are. Are you more interested in accuracy, or are you more interested in performance? Right? So that's obviously going to be relevant to what your goals are. So first of all, what is TCP and what is UDP? So TCP, Transmission Control Protocol. UDP, User Datagram Protocol. So why do you use one over the other? Well, if speed is your priority, is that the biggest focus that you have with your connection? Well, it's an easy choice. You want UDP, right? UDP is all about speed, right? If accuracy is your priority, then you want to use TCP, Transmission Control. Special word is control, and I'm saying thumbs up when I do that because I want you to click on the thumbs up. I really appreciate that. And comment below, say hi, whatever. So what makes UDP faster than TCP? Here's the deal. With UDP, it's a matter of I'm just giving you data. Here's the data, here's the data, take it, right? And while I'm doing this, you could be on the receiving end, you could be like, whoa, slow down, I missed that one. Oh, I got it, oh, missed it, got it, missed it, and every time you say missed it, that's all the gobbledygook and weird artifacts or whatever. Those are your packets that are lost, right? Because the priority with UDP is speed. So it's just, you're just throwing data as fast as you can, not literally throwing it, but you're transmitting the data as quickly as possible. And you have no regard for whether it's even being received. It's like a bad instructor. An instructor that he just goes on and on. So today we're going to talk about this, and you're sitting there still trying to write the first thing that he said like 10 minutes ago, and he's moved on, 3 chapters already. That's UDP, right? So if you want information the fastest possible way, that's how you do it. You just spit out the data and don't care about whether it's received or not. Of course, the disadvantage is, once again, you're going to have problems with the quality of your connection, quality of your data. You're going to have missed data and things like that. Now, TCP, right? TCP, Transmission Control. Big thing is control. Remember UDP, we're just like, hey, take it, right? On the other side, it's like, I got it. Oh, missed it, got, missed it, right? So what's up with TCP? TCP, all right, I have 5 marbles. There you go. I'm messing it up. I got 5 marbles. Here you go. What do you have? Yeah, I just received 5 marbles. Okay, cool. All right, I'm going to send you something else. I got 3 teddy bears. Tell me what you got. Oh, I got 3 teddy bears. So it's a situation where you're sending data, right? And then there is a response back saying, okay, on the other side, this is what I've received. So for example, I'm sending you 5 marbles. I've got 4 marbles. Oh, I sent you 5 marbles. Okay, let me send it to you again. Here's 5 marbles. Oh, I got 3 marbles. Oh, that sucks. Okay, let me send you again 5 marbles. Nope, I got 5 marbles. Cool. All right, I got 3 teddy bears. Received 3 teddy bears. Cool. I got 3 used bars of soap. I got 3 used bars of soap. You get the idea. So it's something where you're sending your data, and then you are waiting for confirmation on the data. So it's like I'm telling you, and also you're ordering your packet. So it's like because you want to have them in the right order, right? You don't want to just make sure they're received. You want to make sure they're received in the right order. So with TCP, it's I'm sending you packet number 1. It has 5 marbles. You respond and say, I've got packet number 1. It has 5 marbles. If you say anything other than that, I'm going to say, okay, you missed something. Send it again. I'm going to keep sending it to you until you get it. And if I keep trying to send you the same thing long enough, or there's enough times where I have to keep resending you something, I'm going to determine that the connection's no good. And that's where you get a timeout message. Right? You get a timeout message, drop the connection. Right? But once I know you've confirmed that you've received it, the right packet number, the right data, you've confirmed it, then I'm going to send you another packet. Right? And then we go on and on and on. This takes time. This takes lots and lots of time. So the simple answer. So what's wrong with live streams? Based on what I've told you so far, most of you, if you're really paying attention, you should know why the live streams are the way they are. Why are live streams so unreliable? Think about it for a second. What could possibly be the reason why live streams are unreliable? I gave you 2 methods, 2 protocols, 2 ways of transmitting data. I will give you a little clue. One of them is going to be how you're going to send your live stream, right? How you're going to send that data, either TCP or UDP. With that being said, why would it be that live streams are unreliable? All right, if you haven't guessed it yet, the reason why you have unreliable live streams is because the protocol of choice is usually going to be UDP, User Datagram protocol. Why would that be? That shouldn't be too hard to figure out, because with a live stream, performance is priority over quality, right? Especially imagine like a gaming connection, right? Your online gaming. I don't want you to keep going back and forth and making sure you get every single pixel information correctly. Meanwhile, the game is continuing, right? Because the game, when you're playing a game, the game is going to continue. So if you have a problem on your end, while you're waiting for these packets, the rest of the players are moving on, right? So who cares that you have this perfectly displayed frame from 5 minutes ago when the other characters are 5 minutes in the future? You're dead at that point. You can't play a game where you're behind. You need to be real time. It's better that once in a while you have little glitches and stuff like that and little weird artifacts, but you are real time or as close to real time as possible so you can effectively play the game. Video, same thing, right? The idea of putting quality over performance doesn't make sense, because let's say this is actually a live stream. If this live stream was being broadcast with TCP, so everything is perfect, all the data is confirmed, then with no distortion, this is how it might play out. So today we're going to talk about UDP versus TCP. So the difference between, so see how annoying that is? Like, that's how it would be. Everything I did, assuming there was no dropouts in this connection, I was still just acting, right? Everything I just did was perfect, right? There was no weird distortion or whatever. The video was fine. My voice was fine, hopefully. But the stopping and stopping and stopping, it's ridiculous. most people would prefer if it was something like, today we're going to be talking about UDP, and we're going to, you know what I mean? Like, I'm not going to act it out. But basically, if you're watching a live stream and every once in a while there's a glitch where the picture gets all fuzzy, now obviously sound is priority. So I'm sure they put that into the programming. You know, maybe you can still hear the voice, but then the picture's all fuzzy, then it comes back. But the main thing is that things are constantly flowing. You don't have a lot of like stopping and all this kind of stuff. And it's a 1 hour stream and it takes you 2 hours to watch it type of thing. You know, people would rather have a little distortion here and there, a little bit of visual artifacts than have to deal with that kind of experience where it's stopping all the time. So, and also you're trying to send a lot of data. You got to also consider bandwidth limitations. You're like, let's say it's an HD live stream, right? So you're just trying to send tons and tons of data to someone. Your ability to do so is going to be limited by your bandwidth. How much data? What's your data rate? What is a data rate that is supported by the system that you're using to broadcast? So being that it's HD, you're going to take up a lot more bandwidth, right? So obviously that can potentially slow things down. So if you're trying to send a lot of data very quickly, the last thing you need to do is to introduce further latency into your connection. So on top of the time that you're waiting to transmit all this data, you're also waiting for all of these checks, right? Checking and validating, you have the right packet number, do you have exactly what I sent you? So you're waiting for the transmission time and verification time. I mean, that could be ridiculous and well outside of the scope of what your system can handle in a feasible manner. So the alternative is you go with speed, UDP. You just throw in that data, as quickly as you can get the data to, wherever you're transmitting it. That's how fast you send it. It's basically your main limitation is the bandwidth. What's your data rate? How many megabytes per second? How many gigabytes per second? Right, whatever it is. As opposed to how many megabytes per second can you transmit, and also how many delays are introduced based on your verification of the data that's being sent to you. So that's additional latency. So that's the basic idea. So the solution to getting better live streams, as far as like the sound distortion and video distortion, getting rid of that, TCP. Send it via TCP. It's going to be a perfect live stream as far as this is just like from Star Trek. Star Trek, I think. Voyager. Is it Voyager? Or is this? I think it's Star Trek. It's been so long. Data's an android on the show, and he was learning how to play music, and he played this classical piece perfectly, absolutely perfectly. So it was actually pretty bad. It lacked any kind of emotion, any kind of feeling, any kind of creativity. It was like he was just doing this mathematical equation, which is not very inspiring, or you know what I mean. So that's kind of the idea here. It's so yeah, it's accurate using TCP. You're getting every single packet, every frame is perfect, all the audio is perfect, but it's a really, really bad experience. I mean, if you're a robot, then maybe time doesn't matter to you, so you don't care that I started talking and then I stopped for 30 seconds and I started talking again and I stopped for a minute. Maybe you don't care because to you those gaps are irrelevant. You as a computer, you just concentrate on or process whatever is being sent. As a human, those gaps, we live through those gaps, right? And it's hard for us to stay focused on something that's constantly stopping and going. It's frustrating to us as humans, right? Because we're not so precise and mathematical like a computer would be. So anyway, that's the solution. Use TCP, but actually, like I said you're not going to like the solution because so you won't have any of this distortion, but then no one's going to watch the stream because it's not real time, it's taking a long time, it's stopping all the time, it's no good. Now, some of you may say, even with UDP, you have the same kind of problems, and in theory, yes, you can. Why would that be? Because with UDP, obviously, you're not checking the data, so you're subject to any kind of interruptions or any kind of issues with your transmission or your connection. So With that being said, if the connection is really, really bad, then even though it's real time, it could be really, really useless. I mean, if half the stream is like you can't even see the guy's face and 30% of the time the sound isn't playing, then it's still no good. So here's the deal. Regardless of whether you use UDP or TCP, you still got to have a certain threshold of quality with your connection, right? You still need to have a certain threshold. Like, for example, if your bandwidth is severely insufficient to what you're trying to do in terms of how much data you want to send, then it doesn't matter what protocol you use. I mean, let's just say you're trying to send an HD live stream and you're using a 56K modem. I'm going to take you guys way back. 56K. 56K meaning you're sending at a rate of 56 kilobytes per second. I believe it's so long ago, but I think that's what it is. So 56 kilobytes per second, and you're trying to send a HD live stream. Good luck with that with any protocol. With any protocol, good luck to you. So obviously, regardless of protocol, there's a certain minimum data rate that you're going to need to be able to sustain. Once you get to that rate, then you have performance advantages using UDP, right? Because you're not doing the checks. And then you have quality advantages using TCP. So let's do a projection into the future. Let's take this and extrapolate where things are headed in the future. So future live streams. Can any of you guys guess how future live streams are going to be conducted? What most likely is going to happen? I think there's one of two things that's going to happen. What's going to happen in the future to live streams based on what I've told you so far, what you've learned today? By the way, thumbs up, really appreciate it. New subscribers, click on that subscribe button and also click on the bell icon and click on send me updates. People complain they don't get notified on videos. That's why. Click on subscribe, click on the bell, send me updates. Also subscribe to my mailing list and take my online courses. Deep discounts for my subscribers. Deep discounts. There's also free courses available. The link is in the description. So what's the future projection? I would say what's going to happen in the future is that one or two things. Some new advanced, there's a couple of things actually can happen. Advancements in compression technology, advancements in let's start with the foundation. Advancements in the hardware. So huge increase in bandwidth, right? Huge increase in bandwidth, such that we move from using UDP for live streams to TCP, right? TCP is more ideal because it's accurate, right? That's going to get you quality. But we don't have the bandwidth to really do TCP. It's not really feasible. However, with increased bandwidth, it could make sense. Actually, it would make sense, right? Because if you have enough bandwidth to send the data so fast, and you have enough processing power, that's the other thing as well, processing power to do your checks fast enough. So you can quickly analyze the data, make sure it's good. If it's not good, resend it again. And it's like, everything's so fast. Like, imagine that you could do 100 resends in a millisecond. So 100 times it says this is incorrect, and you resend it, this is incorrect, and you resend it, and you do that in a microsecond or millisecond, whatever, fraction of time, to where you have enough time to deliver all of this HD data and do your checking, make sure all the data is validated, and do this at near real time to where the user is able to get a perfect viewing experience. There's no distortion, no dropouts and things like that. And that's probably where the future is going. There's also compression advantages, because with more advanced compression algorithms, we can perhaps use the same bandwidth we're using today or slightly higher bandwidth and be able to handle it in real time with TCP. What do I mean by that? We may in the future have future compression algorithms, future technology, where we'll be able to take this large amount of data and somehow compress it into something very, very tiny. So instead of trying to send a 40 gigabyte live stream in 30 minutes or something, maybe you end up just needing to be sending 1 gigabyte, so 40 times less the amount of data, but the same quality, because you're compressing it really tiny on the sending end, and then you're decompressing it really fast on the receiving end, and the end result is what the user sees and what is sent is really, really near identical. But the data that's being sent is very tiny, so therefore you don't require that much bandwidth. So that's one way to go about it. The other thing is perhaps more advanced protocols in terms of how you transmit the data. I'm not sure how much we could, I mean, we're projecting into the future, so who knows what new, discoveries in science and things like that. But perhaps there is something we have not yet thought about in terms of using the same bandwidth we have now, trying to send the same amount of data, but somehow using some new advanced protocol that somehow is able to get the best of both worlds. You're getting something that's pretty accurate, minimal amount of dropouts because you're doing some minimal level of sort of checks, but you're able to get near real time because the checks are being done so quickly, for example. So a lot of different ways to look at it. But another thing, final thought for the day, is that clearly we currently have methods to do pretty close to what I described, because think about the news media. News media currently, I believe, are broadcasting in HD. I don't know if they're using satellite uplinks or whatever it is. They have technology to broadcast HD without all the dropouts and distortion and all this kind of stuff. In fact, look at the stuff you watch on TV. If you're watching satellite television, I mean, right? But the thing about it is making that technology economical to where somebody streaming for free on YouTube has access to the same bandwidth and technology. See, that's what's missing, the accessibility. So it's there if you have enough money currently. Something is there that works, but the cost is probably really prohibitive right now. Anyway, you watching Carl Speaks Wall Street? This is another live stream. I'll try to do as many of these as I can. I'm really, really busy. I'm always working. This is my little binder that I'm working on. I'm doing some research and also working on some projects. This is one of my favorite books I talked about before. As you can see, it's very well used. Look at this thing. Look at the cover of that thing. Very well used. I'm busy. Anyway, I gotta go. Thanks for watching, guys. Thumbs up. Comment below. See you soon.